What's up, guys? Today I'm doing Codeforces Round 657. There will be a total of 6 problems, and the last problem will have 1 subtask, which tells me that it's probably really hard. So I guess maybe I'll only solve 4 or 5 problems. We'll have to see. Okay, this problem does not look doesn't look very nice. As a string exactly once. If it already occurs, or if it occurs multiple times, then we have our answer. Let's like brute force over the position to add, I guess, and then we can check it. Okay. If the answer has like the answer is not empty, then there exists an answer. So the starting index, we can choose it out of like n minus 7, n minus 6. Let's paste t into the string. S2 is equal to s, and then if everything is okay, then answer will just be equal to s2. Okay, if s2 it's equal to the question mark, then we'll just set it equal to whatever it needs to be in the substring t. Otherwise, we need to make sure that it's the same thing, same character as in the string. And we fill everything else with like z's. Finally, count the number of occurrences. We make sure that current number of occurrences is exactly 1. And the way we count this is just go through and make sure that everything matches. And this is not an easy A, so this time I'm going to compile. Oh wait, always forget to read in the number of test cases. So yes, 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 no, no. It works on a sample, so let's hope that it works for all the test cases. Wait, pretest passed. ABC or integers. So this term b minus c, well, b minus c can take in like all values from negative r minus l to positive r minus l. Okay, let me read in the input first. L, R, and M. It is guaranteed there exists at least one solution. Wait, hold on. The numbers are such that the answer exists. Oh, okay, I see. We iterate over b minus c. We check and we find a. And then if it works, then it works. Wait, let me check my template. Does for loop like does it use int? Wait, it uses int, so if I use, so, wait, it doesn't matter. Like, whatever. So I start from negative r minus l, go to positive r minus l. And then for each of these, the x mod we can choose any positive integer n. Wait, we need to decompose it into n times a. What? Are you sure this is a div 2b? Let's look at the... Okay, people are solving B, so I'll continue to solve this. Oh, actually, like, I need to create the range, I think. And then I iterate over A to see if there's, like, possible N. From L to R. This is for A, okay. Divided by A multiplied by A. This gives us a multiple A, and then this is greater than or equal to the lowest. If the lower bound, then that means we have a solution. Now we need to find M minus B plus C. This needs to be equal to M2. We need to find like possible B and C. We can like brute force over B, I guess. C is equal to M2 minus M plus B. And if C is within the range, then we can basically just break. Okay, 4, 6, 13. Hold on. C needs to be within the range. Okay, identified A as 4. Then what? Oh. 2, 3, 1. Wait, this doesn't make any sense. Oh, wait, never mind. Wait, 5, 4, 5, 4. Yeah, that makes sense. And then this is 2n minus 1 equals to 1. Okay, that also makes sense. So, spent 10 minutes on B, which is not. Oh, and then pretest passed, which is good. Someone already solved C. Let me make sure there isn't like, yeah, there probably isn't like overflow, okay. First example, 1 of the first and 3 of the second. Wait, what? Oh, flower of the first type. 3 of, okay. We can iterate over like the maximum B value. Like we will only take the maximum B value, so we can sort by that first. So basically, we assume that we take the flower with the maximum B value, and then now we need to find like, you can like use some binary search to find how many like other flowers do we take. Yeah, I guess that makes sense. Let me compare it based on, actually, okay, the larger B values go first, and then wait a second, we sorted it once by, wait, what am I even doing? So I can use some like priority queue thing. Okay, so assume we choose J such that Bj is maximum among the ones we chose, and then you can put everything else in a priority queue. the sum of the priority queue. Then we also have the answer. Assume that J. Okay, so then I need to iterate from smaller B values to bigger ones. Okay, then if we take this, you have n minus 1 left. Okay, so if we, the top of the priority queue, if it's smaller than the current B value, which is 3 of I of 1, then we don't want it. So we move it from the sum, then we move it from the priority queue. Also, I need to condition that the PQ is not empty. And then we update the answer with, we spend 1 like eating this, like taking this flower. And then we also spend like a bunch of others, like with the priority queue. Okay, so in the end, in the inverse, like we'll add the value of A into the priority queue. Okay, if the PQ is like too big, if it's greater than size of n, greater than or equal to the size of n, then like we can't take that many flowers. Oh, it's like, it's OR condition, okay. Okay, so for the rest of the flowers, the ones that are not in the priority queue, we'll just take the B value, which is like the second element in the array. 14, 6. Oh, what happened? Read. Okay, we're supposed to read M instead. Something wrong happened. It's not N, it's M. Okay, confuse N and M, like in this problem, in my code. 7 and 11, but that's not the answer. Oh, that's because when I added into the priority queue, like, I didn't update the sum. $14.16, okay. This managed to work after 10 minutes. 10 people solved it. Okay, pretest pass. This is like a kind of hard div 2 round. Okay, so looking at the scoring, I should go for D first. what? H is equal to 2. Number of freight trains, okay. Wait, freight trains, oh, okay. The passenger trams are marked in red. Okay. About canceling some of the freight trains. Please optimize value of T. So you can touch the edge, but you can't go inside. That's what I think it's saying. Okay, H is big. This is a lot of information. There's like minimum number of trains to be cancelled and the optimal starting time. First of all, this does not look like a nice problem. But anyways. Oh, okay, yeah. This makes sense. Kind of. So for each freight train, we probably need to take it like... Wait, first let's convert everything to minutes. Like, why do this like hours and minutes thing? It's just... It's kind of unnecessary. Yeah, and then we have H, M, K. So I don't think it's complicated to understand, but it's probably not that terrible of a problem. So first, like, only the residue module, like m divided by 2, actually matters. Yeah, the hour, like, doesn't even matter. You can disregard h entirely. So once we reduce it module like m divided by 2, okay, so t is our departure time, t minus k is our boarding time, anything inside is like not good. So basically they're like k-1 like time points inside this k-1 time points inside. So after that, this problem becomes you can probably do some like two pointers on this. Okay, so for the input, it's hn, and b mod n. So then the two pointers thing. We need the IDs of the trains, do we? Freight trains that need to be cancelled. Okay. That means we do need the ID. We cancel everything inside this range. Okay, so and then the index. We sort it and then we do the two pointers. So what does the two pointers do? It's like we start T at exactly this train so that this train is not included. Okay, that makes sense. Okay, well, v of I of, well, the time is less than or equal to whatever minus k, vj0 minus k. That means we should skip over this. And then j minus I is the number that needs to be cancelled. Optimal starting time t. Okay, t has to be within this range. The answer is minimum number that needs to be cancelled. Starting time. Okay, and then second line is everything which needs to be cancelled. So if time is less than starting time, less than equal to starting time minus k, or is greater than or if it's greater than or equal to starting time, then it's fine. But otherwise, if it's not outside of this bound, then it needs to be removed. Okay, and we update the answer with how many? Okay, so j minus I, and then the starting time is v of j of 0. Yeah, we don't even need 4, we just need 2. Zero 30. Okay. 132. Yeah, I subtracted m, so now it should be fine. Okay, this problem actually isn't that hard. It's just like weird to like read. It took 13 minutes for this. Let's check. Did I have the wrong submission? What? Oh, shoot. I didn't know this would be an issue. But, rip, that means some penalty for me. And F1, someone solved F1. Okay, pretest passed. Oh, cool, I'm the first person right now. I don't know how long that lasts for. The child is actually the parent. This is confusing, like the parented tree. Say that A is an answer of B if A equal to B, or A has a child which is an ancestor of B. So A is a descendant of B. Total number of ancestors of one of the parents is at least double the other. What? So they actually used these people. Funny. Construction. No construction. Why is output? Yes. Or one person has 2 parents. Okay, how's this imbalanced? Person 1 is imbalanced because... Oh. Other parent has 3... Okay. Is more than double, or... is at least double the other, okay. Can one person have more than like this? Like every person has either both parents specified or none. Okay, so we can't do like weird tree stuff. This is the only way you can get 5 nodes, right? Wait, n is odd, right? Is that odd? Except for one special person who does not have any children. Each person has exactly one child. So it's a tree such that each node except for the leaf has like 2 children. This looks like it could be some DP. Either has both parents specified or none. Okay, so n has to be odd. I'll make sure I don't screw myself over by writing this right now. If it's even, then there's no answer. Okay, let me make sure I got that correctly. In this structure, every person has either both or none. Yeah, so it has to be an odd number. Okay. First thing, I'm going to write some like brute force DP. So for one node, you can only have like 0. This is basically DP of 1. That's just equal to 0. Wait. Yeah, okay. 3, and then let's go up to 69, and then with increments of 2 because they need to be odd. And then for a subtree size, go from 1 to I. And go up in increments of 2 as well. So then k is going to be I minus 1 minus j. That's the other subtree size. We can convolute j and k. And when we can like merge the sets. Okay, so this I'm just gonna use a set for convenience. dp of k dp of I. Insert a plus b plus. And then if that condition is true, which basically says one is at least twice the other, j is greater than or equal to 2 times k, or k is greater than or equal to 2 times j. And then lastly, we'll print everything. And we'll see if we can find some pattern. So let's 0, 2, 1, 3, 1, 2, 3, 4. So it seems like okay, you can get, let's see. Let me just calculate this for a bit more. 96, just to be sure. Now put that into Notepad and then. Okay, good. So the first thing is 0 only appears for powers of 2 minus 1. Okay, so uh, 32 minus, I think. If n is equal to 1 to the power of 32 minus built in, leaving basically the log of n minus 1. If this is true, then 0 is basically allowed. Oh yeah, for 1 you're allowed 0. Okay. If k is equal to 0, so I'll have a function called fk. That'll basically help me determine when something's not doable. Otherwise, if we need 0, then it's never doable. But otherwise, how do you, because we need to construct a solution, which is not entirely trivial. Yeah, the construction is a bit hard. how do you get exactly 1? That's like an interesting question. We split it off into like a power of 2 and then something else, I think. Yeah, it's a bit weird. Wait. Okay, HS tells us if there's a solution or not. So otherwise, 4, 3, 2, 1. Everything seems to be like, if is equal to 9 and k is equal to 2. That seems to be the only exception. N is 9, k is equal to 2. Yeah, okay. I'm gonna put some like very obvious cases, like k is less than 0, or n is, okay, k is less than 0, then it's not possible. K is greater than, okay, let's see, 21, let's divide by 2. If it's greater than or equal to n divided by 2, then it's also impossible. Otherwise, like, after all these checks, it should be possible. I think I might want to write a stress tester for this. Okay, yes, and then then this function, which returns the solution, how is it going to work? So if you're power of 2 plus 1 and you have like just 2, wait, so it's pretty obvious to get from nk to n minus 2 k minus 1. And then the construction for like 2 to a minus 1, 0 is also like pretty straightforward. Construction for n not equal to 2 to a minus 1, and then 1, that's also straightforward. Is it? Okay, now we're left with 2 to the a plus 1, 2. Like, how do I deal with this? Do I just split it into 2 somehow? Yeah, I can also subtract 3. No, not subtract 3. Subtract 4. I can subtract 4 to get to the same state, right? I can subtract 4 to get to 1. So 2 to the a n minus 4 k minus 1. So I guess just like basically by using these rules I should be able to construct ideally I know how to construct it in time. Answer, and we start at 0, I guess. And k 0. Then yeah, S is the start. Or n is like n is less than or equal to 0, then we'll just like tell it to stop. n is equal to and k is equal to 0. Then we can just build it already. Starting from I from 1 to n, the answer for s plus I is equal to s plus I divided by 2. Yeah, basically a binary, like complete binary tree. Okay, with that out of the way, now we have if we can transition to n minus 2, k minus 1. Answer for s plus 1 is just s. And we continue to solve and then return. I need to subtract 4 instead. And s plus 3, they both go into s plus 1. Yeah. For 8 is less than or equal to, the remaining size is, no, 6 is less than or equal to whatever's left, which is n minus 4. So I got these rules down already. What if k is equal to 1? Otherwise, if k is still equal to 1, then assert that k is equal to 1 and then find the largest power of 2. If it's too big, then it's going to include 2 times n minus 1 minus 1 to the a. Subtract a, and then assert that there's a solution to I always put this assert at the top, I think. Okay. Assert has solution mk. And then s plus 1 plus the size of that subtree. And s plus 1. And then whatever k is left, and then s plus 1 plus this. Okay, that was a lot of code. Built in. Oh, okay, I mistyped it. Maybe I'm overcomplicating this. Yes, 0, 1, 2. Something's not right. Okay, what happened here? So 3 was passed inside. There are like 30 leading zeros, and then so this was run. Interestingly enough. That's because it doesn't work, I think. Wait. How do you get to the parent cell? 1, 2 both go to 0, and 3, 4 both go to 1. So I minus 1 divided by 2. Zero, 1, 1. 0, 1, 1, 3, 3. No, okay. Now everything seems to be linear time, so let me just do some stress testing. For n from like 1 to this many, 4k from 0 to n plus 1. If there's a solution, we'll run it like and make sure there's no nothing fails and stuff. Okay, something failed. I don't know what it is. Oh. Forgot to make the vector size n. Assertion failed. 13(1). (13)(1), 1, 2, 4, 0. So what happened? Subtracted by 1. Okay, I see. So if this part is less than 2 to the a minus 1, then I'm just verifying it. Okay. And then what happens is this becomes 2a minus 1 minus 1. And then wait, hold on, this might not work. Then you have two to the a minus 1. Realize that this is smaller, so instead give it so it becomes this, but still imbalanced either way. Wait, then how is it possible? Like, let me check 95. How do you get a 1 then? Oh, 31, 6. That means they're both complete. Okay. Minus 1, but it's greater than or equal to. And depending on what happens here, two times this is less than or equal to this, k minus like this condition. And then the rest is n minus this. Let me just check this. 1 and then 2, 3, 4. Five, 6, 7, 8. So you have something complete here, and then 9, 10, 11, 12, 13. Yeah, okay, there's one imbalance. Now let's continue testing everything else. Seems to be good. Yeah, okay, I'll just say that's good. Now I'll go back to testing these. Do some like sanity tests. This looks okay, this looks correct. So let's submit this. This took me almost an hour, so I think I might actually be behind by now. 40 minutes. Not that bad actually. Chess strikes back. It's saying hardware and unavailable cells can become available again. Wrong answer on pretest 11. What? I'm going to try to like see what went wrong. Vector of like children, I guess. It's either 0 or 2, and then size yeah, it either greater than or equal to 2 times the second one, or second one is greater than or equal to 2 times the first one. Did 1 0 fail? What? Oh, never mind. It was just an indexing issue. 5-1 fills. Interestingly. We probably just messed up my check function. Add 1 to SFI. It's at least 2 times the other. Five one answer. Hey, what went wrong about this? This didn't match up. It's 0 the entire time. What? But one is 1 and the other is 3. Wait, what? 1 and 1. Does 0 not have children? Wait, don't need to be subtracting. Like, wait, why am I changing the indices? Two, 2, 0, 0. Okay, I'll only do this if I is positive, I guess. But now it should work. Eleven one doesn't work. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11. I wonder exactly one, but it gave like more than one. Okay, so what happened inside of this? Nine zero doesn't have any. Seven, like 0. Wait, does this work instead? Okay, actually, S plus 4. And 2 and 3 connect to 1. I think this is the solution. Five 57. Once it goes past 65. Okay. Yeah, I should be good now. Then I can submit this. And hopefully I can do like F1. Pretest passed, yay. So now I'm first, but maybe not for long. I need to solve F1 to guarantee first. Field is a chessboard. 200 rows, 2 columns. Okay, 133. So you have a 2 times 6. I plus j is even. You have a 2 times 6. So, and then these become unusable, and then I feel like if the board is big enough, then it doesn't matter at all. So 2, 4. I want to place 3, but then it doesn't work. How does it work in this case? You can choose these 3. Okay, that makes sense. But why n times m in particular? Oh, because you can just choose like the even rows, and then none of the kings can attack each other. So wait, oops. You choose these, right? Yeah. Okay, it works like this. Well, you basically do binary search, right? Okay. First you binary search by answer, and then you greedily place things, I think. Okay. Forgot my template. Wait, where's my binary search template? Okay, function and then lower bound, upper bound. Lower bound, like 0 of them are satisfied, and most q of them are satisfied. Okay, so for these we print out yes. For these we print out no. Read NMQ, and then we have the cells. So this one will store like everything we can't use. And then read in the queries. X, Y. Maybe I should just sort them in the set. I can do some greedy counting, right? D is greater than or equal to n times m. Wait, maybe this is a segment tree problem, but whatever, I don't have time. So let's loop through all of the rows. 2 times n. Oh, 2 times n. Okay. Wait, how'd I simulate it without, like, blowing up? Shoot. Can do like intervals of like how much is not allowed. Okay. So for the first row, you take some intervals. And then next row, the intervals which you are not allowed to take are these ones. So you can actually simulate everything kind of. If for the first row we can take these intervals, then for the second row, the intervals which you're allowed to take so even to odd and then to even. They decrease like this. Take the complement and then you like shorten the intervals, kind of. You also need to use a long. S stores like everything, like all the intervals that we can take. So initially this interval is just 0 to m. Last true was not declared. What? Oh. Y divided by 2. Okay. Lower bound search for okay, for each ci inside c of I, basically the queries, search for this. Okay, after we search for that, you take the previous one. Subtract 1 from to get to the 1. Now if ci is less than the ending position, that means we're going to split. Actually, why not just start from ci plus 1? And if 0 is less than ci, then can add this inside. If ci is c of I plus 1 is less than this, then we can also add this into the interval. Okay, now for each interval, you add the length to the answer. And now let's take the complement. So if, wait, if this was available, then put everything into the vector. If 0 is not 0, then let's insert a 0 into the beginning. If it's 0, then we erase that from the beginning. If it's less than m, then we push back m. Otherwise, we pop back. Then V will contain our new interval. Let's clear S first, and then a new range will be from Vj of 0, V of j to V of j plus 1. They come in pairs, and then okay, if I is odd, then we increase the front. Otherwise, we subtract from the end. And then if it's still a valid range, then let's insert it. Then I claim that like this will be fast enough. Seems that it should. I don't know if it actually will. Okay, so something crashed. Okay, when I try 1, something doesn't work. Wait, what's X anyways? So I also need the index of the query. So Ci of 0 is like the actual value of the query. Ci of 1 is greater than or equal to X, then we just continue. When it reaches 1, then something bad happens that I don't know. Okay, it gets past this point. Should be the back, and if size of V and this is true. So something weird is going on. It doesn't get here yet. Gets past here, and then something weird happens. I think I messed up the order of these two. No, no, and no. How many did it get in the end? Got exactly 1. That's some BS. How many did it get for the other one? Got 2 for the other one. So then I got this much. Place it here and then place it there and said you also get an additional one from like, okay, wait. How did the complement become this? Complement became 2, 3. Okay, 0, 1, and 2, 3. It's only true if A1 is less than M. It's only true if A0 is positive. So what's D now? D is 2. Did a greedy fail? Yeah, the greedy algorithm actually failed. I'm surprised. Oh, okay, then this is probably the end then. Unless I find someone to hack. Let's go check my room. It's probably like high rated people though. So A, B, C, D. people are struggling on E. Let's lock stuff and try to hack. I don't think this will work, but nobody solved E, so don't need to bother looking at that. Let's start from the bottom here. Let me look at M2 to see, like, wait, happened to the source? What happened to Codeforces? It just lagged a bit. Source. I mean, is F that, like, obvious? Seems that F may be easier than E. This makes sense. Wait, I think I might have discovered a solution. Did I? Split into like 2x2 cells and then... wait. Oh yeah, I think I might know the solution for F. I don't know if I could have implemented it in 30 minutes, but... Okay, if I didn't make 2 wrong submissions, I would get first. Wait, no, someone... Oh wow, he solved F1. Never mind then. But anyways, this was a pretty... This was a decent round, but maybe E was a bit tricky to do. Well, yeah, using this observation, you don't need any sort of like data structure. So I could have used the binary search, but anyways, so for you split into like squares of 2x2, and then if any of these squares have both of them occupied, then like the answer is no. Otherwise, you consider the ones that have like the top left occupied and the other ones which have the bottom right occupied. Then basically something must be true. Like all of these type of squares must be to the top or to the left of these type of squares. If so what I mean is that you have a square like this, then if like if within the bottom right, somewhere like within this like region, you have a square which is like this, then the answer is impossible. That's because you can't have like these two squares can't be adjacent to each other. It'll cause like two kings to attack each other. So you maintain wait It's basically maintaining like maintaining the first like structure, which is like an upper staircase, and you maintain another like lower staircase, and you make sure that these two things don't intersect. If that makes any sense. Like the upper staircase contains everything, which is the upper staircase contains everything, all the squares. The upper staircase is like the minimum like region, which is monotonic, which contains squares of this type, and then the lower one contains squares of this type. So then you'd probably or you maintain these inside a set or something, and then every time you add something, basically, for example, if you add something in a lower set, you check it against like the upper set to make sure it doesn't intersect, something like that. But then how do you know when like when the answer is yes again? So that's another issue. Because you need to remove, right? Like that's what this says. If it was available, it becomes unavailable otherwise. Okay. So I need to be able to remove them as well, which is not. Maybe I can do like some sort of, actually divide and conquer doesn't really work. Wait, no, actually like you can change it into a problem where you only add using like the persistent, just like dynamic connectivity. You basically build a segment tree. Each of these like block cells, you can basically create a range for when it's alive, and then you can put it in a segment tree and then do divide and conquer, and then yeah. But this only works if my assumption about this is correct. But anyways, which I don't know if it's correct or not. Yeah, I don't know if it's correct. I wonder if we can like check the code. No, we can't. But anyways, I don't know why I just explained my thoughts for F. I was just like very eager to think about F, I guess. Anyways, third place, pretty nice, I guess. Yeah, thanks for watching. If you even made it to the end. It's been like 2 hours.